Today, Lio's talking about self-hosted Mistral with vLLM. Please welcome Lio to the stage.
Thank you. Thanks, everyone, for coming out. My name is Lio. I'm a CTO of Defang, a Vancouver startup building developer tools. And so the tool we are building is called Defang. Oh, that's surprising. Who has heard of Defang before? Oh, well, okay. Yeah, I have done a demo here at the exact spot, I think, 3 weeks ago. So glad to be back here. I'm going to show how to self-host a AI model, Mistral in this case, a language model on Defang, using Defang. And if I lose my train of thought, it's because I just flew back from Europe and I have a terrible jet lag. So bear with me. So yeah, this is the website, defang.io. Check it out. Raf built most of it. Thanks, Raf, for your help. And I show you this because this is how you can install the CLI to interact with Defang, the tool, to use the tool. But we also have a nice browser for samples, and particularly interesting for tonight will be like the AI samples, so you can filter these samples by labels. So if I type the GPU label, you see we have 2 samples here. And both of them actually have one-click deploy, so I'm going to just do that. One-click deploy. It brings you to GitHub to clone the repository. I'm going to go with Shiny Umbrella, which is what GitHub suggests, and I'm going to create that repository. Now we can look into the repository, what's in there. This is our vLLM sample. It's really fast.
Sorry.
We can also use the CLI to do the same thing. So while that is running, I will also show you the CLI. So the CLI is called, here it is. It's called Defang. After you install it using whatever operating system you have, you pick the installation method. You can also browse the samples here using Defang new. Zoom in so clear. And so, for example, you pick a language, and then you will see the vLLM sample here as well, the Mistral sample that I just cloned. You can also generate a sample from scratch using the AI. I'm not going to show that today. I mean, it's fun. You should try it at home, kind of thing. That's your homework. So yeah, if you pick vLLM here, then it will basically clone on the local folder, and then you will end up with the same thing on your local machine. Going back to my Shiny Umbrella, one of the cool things is that this will immediately deploy the sample. And so if I now go to the portal, we have portal.defang.dev. You can also get there by going to the big portal button on our website. And you can see the Shiny Umbrella is being installed, so it's being built. And this is the one-click deploy. This is what I meant with one-click deploy. It's actually deploying Mistral on the cloud, and you have a UI that you can customize and you can play with. So let's look a little bit more at the code. And so the whole deployment that you just saw is guided by a Docker Compose file. Who's familiar with Docker Compose? Half? Okay. Who's familiar with Docker? Is that a bigger group, or is it pretty much the same group? A little bit. Yeah, so Docker Compose is how you compose multiple Docker projects together. And you can tie them all up. For example, in this case, we'll have 2 services, 2 Docker services, right? Both of them are containerized. One is Mistral, the model, and one is the UI for that model. And the UI is what your browser will be talking to. And Mistral is the container that is actually hosting the language model, and that's the one that is needing the CPU, the GPU, And so all of that stuff is in the compose file. So we'll see here, the service is called Mistral. We want the servers to be running until we stop it. It's using the Mistral official Docker image, so that's the address of the image from GitHub. It's listening on port 8000. And then here, this is the actual model that we'll be using. So the blog, that model comes from Hugging Face. So also here says that you know media token to communicate with Hugging Face. It has resource requirements for this container. So for example, we'll need 8 gigabytes of memory and we need a GPU. All of that is in the compose file. The UI is much simpler. It's again, we want it to run until we stop it. It's going to be, it's not an image, it's not a built image, it's actually from source. So this says build the image, the container image from the UI folder. So you'll see that here on the left. And the Docker file is called Docker file. So if I open this up, you'll see it's going to be using this file. The AI is listening on port 3000 and is using a load balancer. So that's what Ingress means. It doesn't need much memory compared to the model, which needs a lot of memory. The UI only needs 256 megs. And then the UI needs to know where the model is. And so we'll have an environment variable that points to our model. So we see here the name Mistral 8000 actually refers to the first service that we declared in our proposal. Now let's go back. And in the portal, we see everything is green. The UI is running, the Mistral is running, and Defang has generated a URL for us. And now I can click this URL. And so this is, hi, I'm Defang support bar. And so now we can check with this, what is Defang? And this is the UI service, HTTP, whatever you see there on top, Lio UI. That's a URL that we create. If you don't have your own URL, you can also put your own URL in the compose file, and they will use that. And so now you see this is the language model hosted in our playground, because when I do one-click deploy, it deploys to something we call the playground. That is the Defang environment. More interesting to this crowd is maybe really self-hosting it and running it into your own account. So I can also show that real quick. Oh yeah, so we had cloned the vLLM sample using Defang, so I can go there. So this is exactly the same that I showed in the editor. Right? It's exactly the same code. And now I can say deploy it to my own cloud. So I can say I want to use a specific Amazon account. So this is how I pick an Amazon account. So I'm going to export. And now you can see my prompt changes because I'm using a specific Amazon account. Now I can say Defang compose up, which is exactly what the one-click deploy did. So when the GitHub action does exactly this. So now we do this. We seem to log in, so let's do that. So now what's happening is doing exactly the same thing that happened in the GitHub action, but it's going to my own cloud. So let's have a look at what that looks like. Where is my shiny undrop? Oh, here it is. So just to show you guys nothing up my sleeves kind of thing, right? So the GitHub action, when you do one-click deploy, it comes with a GitHub workflow. It does log into Defang, and it does the Defang compose hub. So that is exactly what you see. And now we're doing the same, but we're using our own cloud. And so that's going to run for a while, I guess, because all the building is happening in the cloud. Nothing is happening on my machine. So it just captures these source files that are being used for this project, sends it to your account, builds it there, builds the images, and connects them together, right, the model and the UI service. They talk to each other, and it gives you a URL when it's done. So why is this interesting? Self-hosting. So my computer is a MacBook M1. I cannot run the model on my computer directly. So I need a GPU to run this model. And GPUs in the cloud are actually pretty reasonable, especially the spot market. So who has heard of the spot market? Okay, this is going to be interesting. The spot market is actually a market where you can find compute for cheap. And this is unused compute resources that Amazon has. Azure and Google, they also have a spot market. And you can bid for those resources. And you can get GPUs that are unused. Amazon has a lot of GPUs that are not being used right now. And you can bid for them, and you can get them very cheap. For example, this GPU that I'm using is 5 cents per hour. And so it's perfect for experimenting. And it works well. So I can show you what that looks like. This is the Amazon dashboard that we are deploying to. And how many people are familiar with the Amazon dashboard? About half. Well, there will be a thing here that you maybe have not noticed before, that is spot requests. And so this is a spot instance, and you can see what this is the maximum price. And usually we don't pay that, we pay less than that. What's interesting is the actual pricing history. So here you can see the spot prices for example, for a GPU instance. So you can see now they're around 20 cents per hour, depending on the zone that you look at, and depending on the date range. And so this is very interesting because these GPUs, they change in price. Especially the older generation of GPUs, they get very cheap. And so for experimenting, for hobby projects, the spot market is very, very easy to use. And Defang uses the spot market by default. So by default, when you deploy something with a GPU, we'll try to find a cheap GPU for you. And even in your own account, we'll try to find a cheap GPU. So while that runs, let's look a little bit at the code. So the UI is talking to the model. The model is literally using the Mistral container image as is and listening on an HTTP port, and it offers a OpenAI compatible API. So if you're familiar with OpenAI SDK, you can use that same SDK you just pointed to your own service, to your own Mistral model. And so that's why this environment variable is called OpenAI base URL, because it's the same. It's using the same SDK. And in the source, we'll see the actual magic, if you can call it that. It's using the OpenAI SDK. Again, we get our OpenAI base URL from the environment, which again points to that model service that is being deployed. And it posts a message. It's actually posting our documentation as part of the context. And then it has here the prompt that we use to communicate with the model. So any text that you type will actually be inserted inside this prompt right here. And so, yeah, what you saw earlier, anything that we type here, the browser will make a request to the UI service. The UI service will insert that into that larger prompt that we have, send that to the model service, and the model service streams back the text as it's generated by the model. Maybe leave it at that. Any questions? Yeah.
Can we control the topology of the AWS environment? Like, networking should always flow through this particular transit gateway, or I want to use EKS instead of ECS, which was being used. Can I control the environment itself?
To a certain extent. So the Compose spec has a lot of parameters. So a lot of those parameters we will try to match to AWS. Right now it's ECS exclusively. Eventually we might have other targets. And that is not just EKS. You might be working on DigitalOcean, GCP, Azure. None of that should affect your Compose file, right? So it's all comes down to when you deploy. For example, I'm not sure if you notice, because I have AWS set here, it's the Defang Compose Up is using the AWS provider, in particular the AWS ECS provider. So eventually, if there's demand, we can make an EKS provider, a GCP provider, etc.
And the providers are pluggable?
Yeah, actually the tool is open source, the Defang CLI is open source. The AWS code right now is not, but you could use the CLI as is and plug in your own provider. Yeah, other questions?
So does Defang have a plan to support for Azure or Google Cloud
Yeah.
in the future?
Yes, we are working on DigitalOcean next, and GCP and Azure are following after that. So it's really demand-based. We saw a lot of startups, they want DigitalOcean, so that's why we're working on DigitalOcean first. After AWS.
I mean, you start to choose with AWS, is it because it's
I can't hear you very well.
I mean, you start with AWS, is that because it's the cheapest?
No, it's because a lot of startups have credits, and this allows them to use their credits. Because if you deploy with our tool to your account, you get to use your own credits. You don't have to pay anybody for the hosting, so you can pay for yourself.
I saw it because it's Docker Compose Up, so it gives like a local vibe. Do you have proxying as well? For example, I do Docker Compose Up on my machine. It runs it on the cloud, but it's accessible on localhost. So does it also proxy the network?
So we have thought about that. We don't do that now. So for local development, you use Docker Compose Up. In my case now, it wouldn't work because I don't have a GPU, so I can only do the cloud version. But for rapid iteration, right now, the only option is Docker Compose Up. Eventually, we'll do a proxy kind of thing. No? Thanks, everybody.
Can I get your help?